Now I'm going to discuss about Kirchhoff's laws, and then problems based on that, and then series circuits and parallel circuits. First is Kirchhoff's current law. What is this Kirchhoff's current law? KCL state. What is it says? KCL states that the algebraic sum of all currents entering and leaving a junction or a node is equal to 0. Algebraic sum of all currents entering and leaving at a junction or node is 0. We know already what is a junction in a circuit. Junction or node. Junction means a point where two or more elements connected. Node means minimum more than two elements are connected. So KCL states that algebraic sum of all currents entering and leaving is equal to 0. So mathematically it is expressed as like this: sigma I equal to 0. Sigma I equal to 0. Or the same KCL statement is also mentioned like this: sum of currents flowing towards a junction is equal to the sum of currents flowing away from the junction. Sum of currents flowing towards a junction is equal to sum of currents flowing away. Okay, that means sum of currents entering is equal to sum of leaving currents at a point, at a junction or node. So that is a other statement for KCL. Now, what is a sign convention? Sign convention for the KCL. Consider a example here. A small example. Consider a node A. Consider a node A here. So here at node A, if you see, there are three currents. Here, out of three currents I1 and I2 are based on its direction. We can say they are coming towards the node A. So the arrow is shown towards the node A. So we say that I1 and I2 are the entering currents at node A, and I3 is the leaving current. The current I3, based on its direction, it's flowing away from the node A. So if you apply KCL here, it is shown as, according to the statement. What is the statement? Algebraic sum of currents leaving and entering is equal to 0. So I1 plus I2 minus I3 equal to 0. So see that means here the sign convention, it is given as the currents entering the node is assigned with positive sign, and current leaving the node is assigned with a negative sign. So that is a sign convention they follow. Entering currents with positive sign and leaving currents with negative sign. Now, next, Kirchhoff's voltage law, KVL. Kirchhoff's voltage law statement, it states that the algebraic sum of all voltages around a closed path or a closed loop is 0. Simply, we can say algebraic sum of voltages in a closed path is 0. So mathematically it is expressed as sigma V equal to 0. Sigma V equal to 0. Now, here, see that the sign convention for to apply the KVL, how they are taking. So we see the next slide to understand this. See that sign convention for battery EMF, battery voltage, okay, and then sign convention for IR drop, voltage drop across each element in a circuit. So in a circuit there are voltage sources, batteries, and there are different elements that may be resistor, inductor and capacitor. So these are across these elements R, L, C, we have the voltage drop. Okay, that is mentioned as IR drop. Okay, that means with respect to resistor, we can say it is IR drop. Okay, if that is an inductor, we say IXL drop. If it is a capacitor, IXC drop. Whatever may be the element, just know that that is a there is a voltage drop. So now coming to the sign convention, because I'm talking about the sign convention. Okay, in to write the KVL mathematical expression. So sign convention for battery MFS. See that a rise in voltage is given by positive sign. Okay, for a battery, a rise in voltage. That means if we are going from negative terminal to positive terminal, that means we are going from lower potential point to higher potential point, means that is a rise in voltage. That is given with positive sign, and fall in voltage is given by negative sign. That means if we are going from positive terminal to negative terminal of the battery, that means higher potential point to lower potential point. So that is nothing but fall in voltage, that is given with negative sign. So that is about the battery. Next, sign convention for voltage drop. Okay, here see that with mentioned with respect to resistance drop IR. So here see that when the direction of assumed current is same as the direction of the current flowing through the IR drop, then IR drop is proceeded with negative sign. So here see that the direction of assumed current. So we take an assumed current. We take usually a current is assumed in the in a loop, in a closed path. Okay, to write this KVL equation. So what they are telling is, okay, when the assumed current direction is same as the direction of the current flowing through IR, same as the direction of IR drop. Okay, then that is taken with, the drop is taken with negative sign, and vice versa. That means when the direction of the assumed current is opposite to the direction of the IR drop, then we consider that we take the IR drop with positive sign. Okay, so here look here, you here there is a battery. Okay, this is shown for battery and IR drop. So here the battery is plus minus. Okay, but see that here the this orange color arrow shows our moving direction. Okay, so we are moving from negative terminal to positive terminal of the battery. That means uh, lower point to lower potential point to higher potential point. That means rise in voltage. In that case, V is taken as this battery voltage, V is taken as positive. Here see that next one, the battery. Okay, for the same battery, but we are moving in the other direction. So we are going in the other direction. Okay, compared to the previous case, then that means we are going from positive terminal to negative terminal of the battery. Okay, then V is negative, fall in voltage, because right. Next, IR drop. See here, across this resistance, the voltage drop directions are mentioned. This is plus, this is minus. Okay, now see that now what is that, to write down the IR drop sign. Okay, if the assumed current is direction is same with the IR drop, then that is negative, and vice versa. Here look here, this is orange color arrow is the assumed direction, assumed current direction. So this is going from, okay, from left to right, but see that that is the voltage drop direction. This is minus, this is plus, so the direction is opposite to the voltage drop direction. That's why this drop is taken with plus, right, plus IR. Then see, look at the here next case, that is opposite. So we are going, okay, orange color arrow from left to right, but the IR drop directions are given. This is plus, this is minus. So both are same. That's why this IR is taken with negative sign. So that is about the KIRCHHOFF'S laws. Okay. So both Kirchhoff's current law and Kirchhoff's voltage law. Okay, so its statement and its explanation, how the sign convention is taken. Okay, once again, previous slide, if I consider this KVL here, see that in this, okay, there are four elements shown, and the voltage drops across each element are considered like this. First element, let us say this is, and voltage across this one is plus minus, this is plus, this is minus taken, this is plus, this is minus taken, and this is 3, element 3, this is plus, this is minus taken, and this is element 4, this is plus, this is minus taken. Now, assumed current is shown with this blue color. Okay, blue color one. Okay, this is a assumed current. Okay, now, see that applying the KVL in this loop, what is the expression become? What is the expressions become? We know that if the assumed current is in the direction of the voltage drops, then that is taken, those drops are taken with negative sign. That's why it is written as, see, started from here, this blue color assumed current, okay, and it comes back to here or wherever it is started. So, minus V1, then minus V2, minus V3, minus V4 equal to 0, right? So for this circuit, minus V1, minus V2, minus V3, minus V4 equal to 0. Or other way we can say, multiply the whole equation with minus plus V1 plus V2 plus V3 plus V4 equal to 0. So that's all about the Kirchhoff's laws. Next, okay. Here we have a problem based on KVL. Okay, so see that how to solve a problem, using KCL and KVL. Now see that first is start. Okay, take the circuit, that means draw the circuit first. Next, second, mark the current directions, okay, using KCL. Then mark all the polarities of voltage drops and rises as per the directions of current. Okay, yes or no? So after taking the current directions, okay, as per KCL, okay, this problem they are doing based on both KCL and KVL. So after taking the circuit, they mark the currents according to KCL, then mark the polarities of voltage drops and okay, according to the currents, directions of currents. Last step, apply KVL, okay, different closed paths. Apply KVL to different closed path and obtain the equations and solve them. Okay, so look here. Problem. Calculate the current. Example is one example problem to understand, to get the better understanding on KCL and KVL. So problem, calculate the current through 50 ohm resistor for the given circuit using KVL. So here see that they ask you to calculate current in the 50 ohm. This last element, okay, 50 ohm resistor using KVL. Okay, so see that this is a circuit. Okay, so initially current directions are not there actually. Okay, so only this 3 volts battery, 10 ohms, 15 ohms, 20 ohms, 50 ohms. Okay, so the value circuit, all parameters are given. Then see that how to apply. Okay, we know that already steps we have seen. Mark the current directions based on KCL, then mark the polarities of voltage drops, then apply KVL to write the equations. So here see that. So first, for the first closed path, okay, here they mentioned it as apply Kirchhoff's voltage law to mesh A, B, E, F, A, S. There are letters, right? A, B, C, D, E, F. So here how many meshes we have? 2 meshes, right? We know what is meant by a mesh, right? So here Mesh is nothing but a closed path, doesn't contain any other closed paths inside. So this is one mesh, this is one mesh, okay, this is one mesh, and this is another mesh, right? So here, um, so see that first current directions are taken. Okay, let us say current coming from the supply is I1. Okay, now after point B, it has two different paths. It has two different paths. Okay, that's why current is okay. In the next path is taken as I2. Okay, so that is flowing to this 50 ohm also and coming back here. Then see that this is I1, this is I2 means what is the current here? That is given by I2 minus I1, right? This is I2 minus I1. Okay, if I apply KCL at this point P. Now, so at this point E, what is the current in this direction? This is I2, this is I2 minus I1. So that is given by, outgoing current is given by, okay, what is the current in the 15 ohm resistor? That is I1 minus I2. Okay, not okay, it is I1 minus I2. Apply KCL at this point B. Now, at point E, apply KCL, the current flowing in this path, remaining path, it is given by, if you apply KCL here, it becomes I1, right? So that's how currents in branches, okay, that means supply take currents according to KCL. Now mark the polarities of IR drops and apply KVL. So for the first mesh ABEF, okay, we are going to write the KVL. Before that, mark the polarities of, okay, for mesh 1. So I have taken the, for mesh 1, okay, mesh current is I1, right? So see that current is I1. Okay, here just no need to mention about the mesh currents actually. So we have the currents, okay, based on KCL, right? Based on KCL. So in 10 ohm we have I1, then after that in 15 ohm we have I1 minus I2, here I1. So apply KVL. So polarities of voltage drops are marked. Now write down the KVL. Okay, so see that. So start from here. Okay, start from here. So assumed current. Okay, we are taking a direction. Okay, if the assumed direction is same as the direction of the IR drop, yes or no? It is same as this voltage drop 10 ohms taken with negative sign. So it is minus 10 I1. Then this 15 ohm. Okay. So it is also direction of assumed current is same as the voltage drop direction. So minus 50 into what is the current in 15 ohm? I1 minus I2. Then coming to the battery, it is going from negative terminal to positive, lower potential to higher. That means rise in voltage. So plus 3 equal to 0. Okay. So the equation is simplified and we get the equation as minus 25 I1 plus 15 I2 minus equal to minus 3. Okay, this is the first. Okay, writing the KVL equation for the first closed path. That means first mesh. right? Next, for the next closed path, what is the next closed path? Here, BC, DEB. Okay, here see that in 20 ohm, what is the current? I2. And in 50 ohm, current is also same I2 only. In 15 ohm, we have I1 minus I2. This is I1 minus I2. Okay, now see that, assume the current direction like this. Okay, now, so if the assumed current mark the polarities plus minus. For 15 ohm, we know that this is plus, this is minus. So minus 20 I2, minus 50 I2, right? Minus 20 I2, right? Because assumed current direction is same as the IR drop direction. So minus 20 I2, 50 also the same case. Minus 50 I2. Look at the 15 ohm. 15 ohm, assumed current direction, okay, flowing upward. But what is the voltage drop direction? This is plus, this is minus. That means opposite. That's why that becomes plus drop, plus IR drop. So plus 15 into its resistance into the current flowing in 15, I1 minus I2. So equal to 0. Simplified, the equation minus 85 I2 plus 15 I1 equal to 0. So that is the equation 2. So last is the equation 1, this is the equation 2. Two equations, two unknowns I'm solving. So we get, okay, I1 equal to 0.134 amperes and I2 equal to 0.024 amperes. What is the question? They asked to find the current in 50 ohm resistor. So in 50 ohm resistor, the current is I2. So the current is given by 0.024 amperes. So that is how problem, okay. So that is how problem is problem based on KCL and KVL. Next is small problems continuation. Okay, small circuit is shown here. Um, Here, see that in this circuit, this there is a 10 amperes current source. Okay, here source is 10 amperes current source, and there are different resistors. Okay, connected, and the current flowing through the elements. Few elements is directly given. So in the first element, if you see, that is 5 amperes current direction also shown. Okay, its direction. And in the next vertical element, current is 2 amperes given. Okay, so it's a current a units. Okay, a is mentioned means the current, it is current value given. Okay, know that it's not the resistance. If it is resistance, they mention ohm symbol. Okay, so it's given 5A means current flowing through that resistor is given. Okay, next element also 2A means 2 amperes current is in that element, it is flowing. Then if you see this horizontal element, current flowing in that element is I3, and the next two elements are current in them is mentioned as I4 and I5. So not given the values, but they mentioned the current in the one element is upper one is I4 and the down is current I5. So question here is using the circuit given, we need to find the this unknown currents I3, I4, I5. So hint is given, okay, based on KIRCHHOFF'S laws. So this whole circuit is talking about showing about the data current. So we have to understand that first point. This circuit we need to solve by using KCL. So, in order to find current I3, okay, if you look at the node B first, okay, you can start doing from node A. Okay, if you look at the node A, there are incoming currents and there are outgoing currents. So there at node A, 10 amperes current is a current coming, and the two based on the directions of this arrow, right? So this 10 amperes arrow is shown up means this current is coming towards the node A. So that is incoming current, and the two there are two outgoing currents. Okay, this 5 and other one is I4. So 10 equal to 5 plus I4. Okay, so only the unknown is I4. So here I4 is given as I4 is given as 10 minus 5, 5 amperes. Next thing, apply KCL at node B. So here at node B, if you see there is a 5 amperes incoming current and 2 and I3 are the outgoing currents. So 2 plus I3. So I3 equal to 3 ampere. Next, at node C, if you apply KCL, I3 plus I4 equal to I5. So I3, I4 already solved, already calculated. So 3 plus 4 equal 3 plus 5 equal to I5, that is equal to I5 equal to 8 amperes. Okay. Next problem, we come this side. So the small circuit shows all about the voltages. So we have to know that this problem need to be solved by using KVL. So here source is given 10 volts. Okay, this is plus, this is minus, and the next element, this is VR1. They mentioned that means voltage drop across, that is 4 volts, and the next element is VR2, that is not given, question mark, and next element VR3, a voltage drop across, that element is given 2 volts. Then how to find this unknown voltage VR2? So what to do is apply KVL in the loop, so in the closed path. So if you apply closed path KVL, okay, so what is that we get? So we know that if we so based on that, so this is a equation. So okay, these are the assumed current. This red color arrows are showing the assumed current direction. So actually, okay, so minus VR1, minus VR2, minus VR3 plus 10 equal to 0. It's written other way here. So here exactly to say minus VR1, minus VR2, minus VR3 plus 10 equal to 0. So this can be also be written as like this. So if you multiply whole equation with minus VR1 plus VR2 plus VR3 minus 10 equal to 0. So only the unknown here is VR2. So the remaining two are substituted, VR1 and VR3. So we get VR2 value as 4 volts. So that is about this problem based on KVL. Next is about the series circuits. Okay. So what is meant by this series circuit? What is meant by this series circuit? So here, first point is a series circuit has only one current path. That means current flowing through each component is same. In a series circuit, the current flowing through each component is same. See first, basically, what is meant by series circuit? Okay, see here, there are three elements. Okay, this is one element, this is second element, this is third element. See, series connection means, okay, if the second terminal of the first element, this is first element, this is second, this is third. Okay, so if the second terminal of the first element is connected to the first terminal of the second element, and the second terminal of the second element connected to the first terminal of the third element, okay, and the second terminal of the third element connected to the supply negative. Okay, so okay, see that here uh, supply may be or may not be there, but simply series circuit means connecting the elements like this. Okay, in series. Okay, so this is first element, second element, this is first element, second, third. So if the second terminal of the first element connected to the first terminal of the second element, and second terminal of the second element connected to the first terminal of the third element, and so on. Okay, so here just mentioned about just 3 element series connection. So here the point is, when in a series circuit, the current flowing through each component is same. Okay, so that is what. So when a supply is connected, to these 3 elements, what happens? So let us say voltage V is applied, there is a current starts flows in the circuit. Okay, current starts to flow in the circuit. So the current is, let us say, I. So the same current flowing through the each component. So that's a meaning. Okay. Now second point is the voltage drop. Okay, but the voltage across each element is a fraction of the total voltage. Okay, voltage across each component, each element is a fraction of the total voltage. So here, if it is a voltage first element, the voltage across this is, let us say, V1, voltage drop across this element. Then voltage drop across the second element is V2, and the voltage drop across this third element is V3. So here, uh, here the voltage across each component is a fraction of the total voltage. So this is V1 across the first element, V1 across the second element, V2 across the third element, this is V3. Okay, the sum of all these three, the sum of three, okay, is equal to total voltage. Sum of all the voltages in the circuit is equal to the total voltage. So here 3 elements. Okay, so 3 voltage drops, V1, V2, V3. So the sum of the 3 simply equal to total voltage. And last they are telling is, in a series circuit all elements must function for the circuit to be complete. Okay, that means to get the current, okay, for the continuity of the current in a series circuit, all elements must work. Okay, they are telling. Next, when resistors are connected in series. So we know what is a series circuit mean. Then when number of resistors connected in series, what is its equivalent resistance? So based on the knowledge we have this about the series circuit, see that here, let us say, consider 2 resistors R1 and R2 connected in series across a voltage. Okay, let's say here R1 and R2 are connected in series. Okay, that is shown, and that those two are connected in series across a voltage V. Okay, then what happens? Automatically we know that there is a current flowing in the circuit. Okay, which is same for the 2 resistors. So I current flows through element resistor 1 and resistor R2 also. And also, what is the voltage drop across each element? First element, let us say V1, and across second element, let's say V2. Okay. Now, okay, and also we know that V is equal to V1 plus V2. Now, from Ohm's law, what is V1? From Ohm's law, V1 equal to IR1. What is V1? Voltage across the resistor R1. Okay, so current flowing through that resistor R1 multiplied with its resistance value gives the V. Next, V2. V2 is given by in terms of its current and in terms of its resistance. Okay, that means IR2. So V equal to V1 plus V2. So substitute in terms of current and resistance. Okay, IR1 plus IR2 equal to, what is a V? V is given by in terms of current and resistance as I into total resistance of the circuit. That means R equivalent, right? So R equivalent. So cancel a similar term on both sides. Okay, left hand side, right hand side, I gets cancelled. So R equivalent is given by R1 plus R2. So when two resistors R1 R2 are connected in series, its total resistance, its equivalent resistance is given by R1 plus R2. Simply the sum. So let's see an example, small example here. The resistors in series circuit are 680 ohm, 1.5 kilo ohm and 2.2 kilo ohm. Okay. Then what is the total resistance? What is the total resistance? So here the circuit is shown. Okay. 680, 1.5 and 2.2. And supply also given 12 volts, but that is not required actually, because they have given individual resistors and they asked the direct total resistance. So simply they mentioned because they are in series circuit, series connection. So we know how to calculate its total value. So that is given by R total equal to 680 plus 1.5K plus 2.2K. So 680 plus 1500 plus converting kilo. Kilo means what is 1K equal to 10 power cube. So 1.5 into 10 cube. So 1500 plus 2.2K means 2200. So total value gives 4380 ohms, and that means 4.38 kilo ohms. Next, voltage sources in series. Find the total voltage of the sources. Find the total voltage of the sources shown. So here, see that actually that is shown in the right hand side. 3 voltage sources, okay, 9 volts, 9 volts, 9 volts are connected in series, okay. So they're asking total voltage, okay. So we know that in a series circuit, okay, the total voltage is given by sum of the all voltages. So that's why V total is given by 9 plus, okay, 9 plus 9, okay, V1, V2, they mentioned it as one source V1, one other second source V2, third source V3. So simply 9 plus 9 plus 9 is equal to 27. Next is parallel circuit. Okay, see that what is this parallel circuit? Now, in parallel circuit, a parallel circuit has more than one current path branching from the energy source. Okay, parallel circuit has more than one current path. And okay, see that, okay, it is exactly contradiction to series circuit. Okay, in series circuit, current flowing through each element is same. But here in parallel circuit, okay, parallel circuit has more than one current path. Means each element has its own current. Okay, that's why it is mentioned as, okay, it has more than one current path branching from the energy. That means it is a fraction of the total current coming from the supply. Okay, so if you look at this first figure, okay, if Vs is a supply, so then let us say that current coming from that is Is. Okay, if supply is a Vs, accordingly current also there is a current because there is a closed path, okay, with different elements, okay, R1, R2, R3, so there is a current starts to flow from the supply. So here let us mention that Is, current coming from the supply, voltage is Is. So this is going to, total current is going to divide across all these parallelly connected elements. See that, look at the parallelly connected elements. Okay, means see that how the what is meant by parallel connection. See, let us say, okay, here four elements are shown. Okay, see if the first terminal of all elements R1, R2, R3, R4. If the first terminals of all elements in the circuit connected to the same point, okay, and second terminals are also connected to the of all elements also connected to the same point, okay, then we say that that is a parallel connection. If the first terminals of all elements in the circuit connected to one common point and the second terminals of all elements are connected to the another one common point, then we say that that is a parallel connection. Here, that first terminal is, let us say, supply positive, and the second terminal connected of elements is connected to the negative terminal of the battery. Okay, that is what's shown here. Okay, so now see that. So if IS is a current from the supply, this battery, then I1 be the current flowing in R1. Okay, this from this IS, a fraction of current I1 is flowing to the R1 element R1. Then current I2 flowing through the second element R2. Current I3 flowing through the element R3. I4 is the current flowing through the element R4. Okay, so here the sum for all these currents I1 plus I2 plus I3 plus I4 is equal to total current, that is IS. Okay, now voltage across each pathway is the same. Okay, in parallel circuit, voltage across each element is same. Voltage across each element is same. Okay, but current flowing through each element is a fraction of the total current. So here the voltage across each element is Vs. Voltage across R1 is Vs. Voltage across R2 is Vs. Voltage across R3 element is Vs. R4 also Vs. Okay. Now see that this is just for an understanding. Okay. So see that 5 volts battery only. So for 5 volts battery only, this R1 is connected, R2 is connected, R3 is also connected. So battery, okay, shown here. Same battery shown here, here, here. Okay, in parallel circuit, separate current paths function independently of one another. Yes, already we know. So here, battery is connected to a LED bulb and an incandescent bulb. Okay, so these are parallel connections. See that bulb, these bulb two terminals connected to this bulb first terminal also connected to the plus terminal of the battery. Okay, and the second terminal of the first lamp connected to the negative terminal, and the second terminal of the next bulb also connected to the negative terminal of the battery. Okay, here the positions of the lamps are changed. Okay, but this is also a parallel connection only. So this is a simple circuit in parallel. Okay, here all the batteries are connected in parallel. See, look at the batteries. Okay, if there are 4 batteries, all positive terminals are connected to one point, upper point here. Okay, this point, common point, and all negative terminals are connected to the one point, common point. So here the voltage is the same across all batteries. Okay, but current supplied by each element is a fraction of the total current. Now, on the from the knowledge of this parallel circuit, we see when resistors connected in parallel, what is its total value. So here, let's consider two resistors in parallel R1 R2. Okay, R1 and R2 connect. Okay, its first terminals of both are connected to the supply battery positive terminal, and its second terminals are connected to the battery negative terminal. So then what happens, we know that current so current I flows in the circuit, and the voltage across each resistor is V only, right? But what is the current in R1? Let us say that is a fraction of current I1, and current in R2 is I2. So here I is equal to sum of the two currents. We know that. Now write down, we know that I is equal to I1 plus I2. So based on Ohm's law, write down I1 and I2. Write down I1 and I2 in terms of voltage and its resistance. So I1 is given by V by R1 and I2 is given by V by R2. So I is equal to V by R1 plus V by R2, right? V by R1 plus V by R2. Taking V out, V into 1 by R1 plus 1 by R2, that is equal to I. What is I? Total current. So let us say V by, write down from Ohm's law again, I is equal to V by total resistance of the circuit. That is also nothing but equivalent resistance. So continuation, cancel the similar term on both sides, that is V is gets cancelled, so we get 1 by R equivalent equal to 1 by R1 plus 1 by R2. See, this is a equivalent resistance expression when two resistors R1 and R2 are connected in series. 1 by R equivalent equal to 1 by R1 plus 1 by R2. That means R equivalent is given by R1 R2 by R1 plus R2. Product of the two elements, two resistors divided by sum of the two resistors. If n number of resistors, okay, R1, R2 and so on Rn connected in parallel, then it's equal, from the above knowledge we can write this, okay, 1 by R equivalent equal to 1 by R1 plus and so on 1 by Rn. Okay, so that means this is the expression we can get. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.